No, I don't see anything.
Oh, thanks for that. Okay, well, in which case I suggest what we'll do is we'll move on, since time is running short. Actually, not too bad. Hans Martin, it's only a few minutes out. To Markku Parkkonen from Finland, who's going to talk to us about how to craft student worksheets efficiently. So, Markku, you have the ball.
Thank you. Good afternoon, everyone.
Good afternoon. Yeah, that's good.
Just a moment. So you can see my screen now.
Yes, perfect.
Okay, I will give a short presentation about practices, how we in Finland work with our students using TI-Nspire, crafting worksheets, or actually our students use this to do homework. Also their exams are digital. We have had to program special tools to make this possible for our students to do all their drawings, which we used to do in past with paper and pen, in this new digital environment where we are. So we are mainly working with computer on our classrooms, and final exams actually we're not even allowed to bring a paper or calculator there, so we will do it fully with computer. So we developed a few years ago, maybe already 5 years ago, drawing tool for physics, and now we have this drawing tool also for chemistry and mathematics. And I suppose this is not the case in many European countries, that you need to draw as we do here without paper and pen, but this would be useful also in other countries for teachers, for example, when they are preparing worksheets for students or exam questions with pictures. It's up. I will encourage you to test and examine this option, which now is available within the TI-Nspire. You can start during the presentation or afterwards visiting the TI-Nspire-widgets.com. We have uploaded there the widget files for chemistry, math, and physics, which you just download and install to your Nspire CX folder under documents. There you have my widgets folder, and when you upload those widgets under this folder, you can easily add them to your documents within your Nspire software. Here you can see a short presentation of chemistry, physics, and mathematics, how many different kind of illustrations can be drawn at this point with these widgets. Here are just only a few examples. So we have this digital elephant in our classrooms. That's why we have developed this tool to make it easier for the students to operate with the computers. So I will let you decide whether it's easy, slow, or fast. But at this point, my experience after a few years is that force diagrams look better than they look with paper and pen. Even I think that it's sometimes quicker to draw graphs like this than it was to draw with paper and pen. But let's see, I will start with a few examples regarding energy. I will talk about heat, mechanical energy, and maybe some examples from nuclear energy. Back to Nspire. So I have an empty worksheet here. I will just add a widget. Sorry, this is in Finnish, but I will be mainly drawing, so maybe the language is not the issue. I will open the physics drawing widget next. And actually back to this web page, I will show you at this point, we have localized this to German, Danish, French, and Portuguese and Dutch languages. probably some new languages in future. If you're interested, contact us. We can see what can be done. Okay, I will start with energy diagram. It's under heat. This is just a simple platform for the students or teachers to illustrate how the energy is transferred from a form to another. These are just objects that you can move as you want. Last week I did with my students a lab exercise where we calculated the efficiency of water boilers. We measured the temperature during we were boiling the water, and from that we calculated the efficiency of these water boilers we had in our classrooms. So first we had electric energy that transformed to thermal energy, but not all. Some of the energy I will add here, it was the thermal energy of water, but there were also some losses. Just to show that these kind of diagrams are quite quick to draw and formulate, and just take a screen capture and add on your answer on your homework or your exam answer. I will just illustrate some of the tools we have. We can also add a coordinate axles if we want. There are options to hide the numbers there. I can hide the grid from the background also. Actually, this was something that we got as a result. The temperature of the water was rising. Here we had the temperature. Sorry. And we analyzed the data. We did it with the data quest application, and then we got the slope. I think it was about 0.4 degrees per second. That slope there. From that, we calculated the efficiency of the water boiler. My students usually split the screen, and then we do the calculations and text on these notes applications. Here we can calculate to save time. I will not do the whole calculation here. I will jump to my next example for you to see different possibilities that this physics draw widget has. I will add a new question with the new widget, and again the physics widget. Here you can see. Next to mechanics, I will draw an inclined plane. With short keys like tabulator, I can change the direction. I can mirror it from these active points. I can grab. This is just the inclined plane, and I can put an object on the inclined plane. And our students need to draw force diagrams often when they have mechanic questions on their homework or exams, and we have possibility to draw gravity, force of gravity just by pressing G. I got it quickly there. I can show components, and I can change the direction of x-axis to that direction. That makes it easier for me to draw the normal force. And if we have a friction here, I get a force vector just by pressing F, like force, and I can name it just by typing F and My. I get F mu. I suppose this tool would be useful for teachers drawing these diagrams for exams, multiple choice questions. That is what I have been doing. Even if you do it on paper, you can just copy paste these images to your existing documents. I could draw here also a next object. What happens when this box has been sliding down this inclined plane? I could copy that object here just by choosing it with this tool and pressing enter. Like that. And then I could draw a new force diagram. I'm sorry, this energy diagram like this. First, we have potential energy. And in the end, we have kinetic energy. We are preparing an English video, and it will be on that webpage which I showed you in a few weeks' time. And there we will represent these features also. Yeah, I could add, this would be the part that turns out to be heat by the work done by friction. I could write here that this was the work done by friction when the object was sliding on the inclined plane. Okay. Next example would be of modern physics. Again, open a new exercise and add a new widget. There, I will show you how we drew energy states of hydrogen atom with my students just actually today. So I'm teaching physics on a high school level. This can be done in many ways. For example, using the equation like this. I will have the calculation on a different math box than the equation. This time I will try that would be enough to demonstrate. Here we have the energies. So we have a special tool to draw these energy states for atoms. It works so that I just input those energy levels and it will draw me those lines, as you can see. I need to check that last value. So what I can do, I can also draw transitions in this graph, how the energy levels are changed, for example, from this state number 1, we could jump to state 3. I will name these states quickly. This text box I get just by pressing a space bar, so I can write text. And so on. As I showed earlier, we can copy objects and turn them around by tabulator, and then we can adjust them as we want. Next, I will add a photon. From this transition, we could get a photon wavelength maybe longer than the photon from this transition. There's more energy involved here, so the wavelength is shorter, frequency is higher. We could calculate here next the wavelength, maybe this transition. Just a moment, I will do. Draw. No, I'm back to the computer page and view, which is of course preferred here. So now I drew the energy state diagram. Next, I will calculate the wavelengths. This is now a realistic picture of how it looks like when I'm working in my classroom. I'm not using the chalkboard or document camera these days. I'm mainly doing my work in front of the classroom with Nspire, writing my notes here on the notes application, drawing the illustrations here with the physics widgets. So next I will show you how we write equations. They are inside the math boxes. Here is the math symbols. So I will do this by calculating how much the energy changes during those states. And from that, I can calculate the wavelength. We could use the gas tools to solve equations, but these kind of simple equations we do by hand with our students. And next math box to do the calculation itself. And what I really like and love myself with Nspire, when working with Nspire, these constants, we get them immediately. We don't need to look books to copy them. We save a lot of time when we can just use these built-in physics constants and also use the units system, as you can soon see. So we are doing the transition from this energy level 3 to energy level 2, which means that energy will change from -1.511 electron volts to -3.4 electron volts. And now if I press enter, I should get the answer in meters. Answer would be 656 nanometers. Isn't it that? Yes. I will show you quickly some other examples. Just a moment. And actually, last example would be just a pure calculation. Maybe before that, I will show you quickly how this physics widget started, what were the first features in that. And it was about electricity and circuit diagrams. For example, just by pressing R, I get a resistor. I can give a value for its resistance from keyboard just by typing this, and I can copy it by pressing enter. Probably this could be something that teachers would easily take advantage of when preparing paper worksheets or exams, just using this as a drawing tool and then copy paste these screen captures. I'm drawing these straight lines with mouse right button. If I need a battery, I just press B. There I have a battery. If I want to add ampere meter, I just press A. You see And if I want to measure voltage, V gives me a voltage meter. And again, these lines with the mouse right button. If I want to mark that the current is going upwards here, just the text box by pressing the space bar. Current I is, let's say it's 2.5 amperes. Arrow up or arrow down, I get option to add these arrows beside the text box. At this point, I will check if there was, maybe I saw some question. Just a moment.
Yeah, you're looking at Hans Martin's question.
Yeah, actually, I missed it. I cannot see it anymore here.
I can tell you what it is. He asks if widgets support an interface into or out of BASIC or Python code.
I'm not sure if I understood the question.
We'll get him later. When you finish, we'll ask him to explain the question. And then...
Yeah, actually, I have just a few minutes time here, so
okay.
Maybe it's a good time to ask. These have been programmed with Lua programming languages, which is inside TI-Nspire. And only interface we have is this mouse and these menus we have built. So this was for physics, maybe just a short demonstration about the map widget. For example, we can draw many things, of course, but for example, vectors. This is a notation mainly used, I think, in Finland for vectors. As you can see. So we have had local needs, which we have covered by doing these tools. We can calculate vectors. For example, sum of vector A and B would look like this. So on. Just one short demonstration of the math widget, and then we have the chemistry widget also. As you can see, we can draw this kind of images or add objects to lab reports. We are adding more and more of these items, so we are just getting ready the next update with more chemistry devices and items objects. So I think it's the last minute going on, so it would be a nice place to ask if there is any questions.
Okay, well, thanks for that, Markku. There is that one question from Hans Martin. Yep. Hans Martin, you can control your microphone, so could you explain exactly what you mean by the
oops. Okay, can you hear me?
Yes, I can hear you.
Okay, wonderful. Yeah, thanks, Markku. This is actually the first time I saw widgets in life. I always asked myself, what are they good for? And I think I at least understand they are great for documentation and visualization. My question was, okay, is there an interface that, I don't know, the numbers you have in the widgets, either created by formulas or by graphs, being transferred into a Python program in some sort of interface to make it more interactive, or am I missing the intent here?
we have had some discussions about next step. Would it be to build a kind of simulation environment? Now these are static, mainly static images, but would it be possible to make kind of simulation, meaning that, for example, if I had here a lamp, it would go on when the circuit is on and so on. Now you can manually change the brightness of the lamp, but yes, we have been thinking of future development to make this kind of a tool for simulations also. I don't know if this answered your question, but
yeah, somewhat.
yeah, this could be also done with Lua. I think we might not need Python for that.
Okay, yeah, so maybe we could think of sliders or whatever being implemented in widgets, and then if you can control the voltage by cranking up or down the slider, and okay.
Yeah.
Thanks for that, Hans Martin. I do have another question for you, Markku.
Yes.
In your experience, because students are forced to use these widgets and draw diagrams and stuff like that, do you find that in general they're more accurate and more precise in the way they answer questions?
At least with these force diagrams, they look much better than they look on the paper and pen years.
Okay, because my experience was in the past with pen and paper diagrams, students would draw something and it would never really look like what it was supposed to look like. And they never really could understand what was supposed to be going on because they got the arrows in the wrong direction and blah, blah, blah. But
and also with these electric circuits, it's quite easy to produce this kind of quality. So I'm happy with the quality of the images, but the physics, it's still as difficult as it has been in the past for the students. This doesn't help with that.
All right. Okay, well, Stefan has posted, sorry, you've got a question, Christine?
Yeah, there is another question in the Q&A from Frederick Foch. And he asked, can draw object properties be used in calculations? For example, can the angle friction of a plane be used in calculation?
In theoretically, it could be possible, but we haven't opened that option. These objects are saved as variables. So if I divide this screen to 2 and add a nodes application, and then I check what variables I have, there are lots of variables there. But we haven't been thinking of that you could, for example, take some angle from the picture itself and use it directly here in the calculation. That is an interesting idea.
Okay.
Thank you.
And I just wanted to point out to attendees that Stefan has posted some links to the widgets in the chat room. He's also posted some links to Franklin Nate's resources on the T³ resource portal. So if you want to have a look at the chat room and get those links down, it'd be a good time to do it. Okay, well, unless there's anything else, Christine?
No,
yeah, okay.
no, it was this one.
We'll move on because time is running a little bit out. Thank you very much for that, Markku. That was absolutely fascinating, and I wish I was back in the classroom now doing something completely different. Anyway, so